Hello, class. I chose to construct the response for question 4-3, which says to write an expression for the area of the square EFGH in terms of the length of its sides. So this is what I was given in this picture right here. And we know from what was stated that this is a square and there's a square within a square, and all these triangles are right triangles that are congruent. So, first we're going to fill in what we don't know in order to find the area of this square outside. So we don't need to mess with the middle for this part. So I know that B and A are the length of this triangle, right triangle. And since it's a square, I know that all the side lengths have to be equal. So we can't have a B plus B equaling an A plus A. So if I were to put A right here where I put B, that would be A plus A and then B plus B, like I have written in this explanation. And that would not give us a square. That would give us a rectangle. So that is why I decided to make sure I have an A and a B placed like so. So now finding this area, I have to remember that the area of a square is length times width. So for example, HG right here times FG gives me an area. And I could do either of the two lengths. I just chose these two. So this can be written as A plus B times A plus B, or A plus B squared, equaling our area. So part 2, write an expression for the area of the square, the same square, in terms of the area of its component parts, meaning using our different shapes. So we're using the triangles and this middle square. There is a way we can do this, and this provides more visuals for you. So we must fill in the missing lengths of this inner square for this part. We know since it's a square and we're given that one length is C, the others have to be C because the square has equal lengths. So for a visual, we're going to find the area of these shapes in total, and that's going to be our middle square area plus our 4 triangle areas listed here. So for example, let's start with the middle triangle area, which is length times width, and so C times C, again, you're not going to do C times C times C times C. That will not give you your area. You only do length times width. So just pick 2 since it's a square. That'll give you C squared. And then moving on to our triangles, we know that all these different triangles are congruent, which means they have the same base and height, or length times width, and if you want to name it that, base times height. And so for a triangle area, you have to know that area equals a half times base times height. So for this triangle H, which is shown right here, I just moved it right here as a part of our section. We know that the base is A, the height is B. And so area equals a half times A times B, which can give you a half AB. And then if you multiply just one triangle, you know the rest. You got the area for one triangle, so you can find the area of 4 total by multiplying it by 4. So that is what I have written here, which is 4 times our area of one triangle equaling to AB. So now we're going to combine the areas of all of our shapes, getting area equals C squared, which is the middle square, plus 2AB, all of our triangle areas. And our last part of this problem is setting these two expressions equal and showing that it leads to the proof of the Pythagorean theorem, which is a squared plus b squared equals c squared. Okay, so expressions are not equations. Expressions have numbers without the equal sign. So, as you can see, these are my two expressions that I set equal to each other, which was c squared plus 2ab, which we found in the previous part, equal to also a plus b squared, which was what we found in part 1. So we're going to manipulate this equation to get our Pythagorean theorem. I'm going to multiply out this part and see if we can get different values to make this section 2ab go away, because we need c squared. So I'm using a table of a sort, and I love using this method. It's very visual. So I put my a plus b on one side and a plus b on the other side. And I know I have to multiply out these two. And so a times a squared, a times b, ab, b times a, b, and b times b is b squared. So now I'm going to add all the different squares together, like so. We get a squared plus b squared plus 2ab, and we can now have our equation equaling c squared plus 2ab equals a squared plus b squared plus 2ab. I can now cancel out 2ab, because if I subtract from both sides to cancel it out, I will get 0 on this side. And so I have c squared equals a squared plus b squared, which is the exact same formula for Pythagorean theorem. It's just switched around. So that's equivalent to our goal here, a squared plus b squared equals c squared.